probability theory, actually. So what is probability? It is a branch of mathematics that is widely used in genetics, insurance, medicine, sociology, marketing and finance, computer science, and stock markets. In insurance, especially, most of the premiums are calculated based on probabilities. In terms of computer science and information technology, there are wide applications of probabilities. One of the applications is the error detection and AI in terms of robotics and autonomous systems, assessing the likelihood of attacks and anomalies based on patterns in network traffic, evaluating potential security threats and their impacts, spam detection by using certain words. We will be able to detect spam, and of course, evaluating the reliability of software systems and predicting the likelihood of failures. These are just some of the examples of applications of probabilities in information technology. Of course, there are hundreds of applications which you can see if you're going to delve into the applications of this particular concept. So probability is simply the likelihood of something happening, and it is uncertain. So it is a measure of uncertainty because we don't know exactly whether it's going to happen or not until we conduct trials and produce an outcome. So it is the chance that a given event will occur, and it is a branch of mathematics concerned with the analysis of random phenomena. When we say random, it means that all the elements have the equal chance of being selected. The outcome of a random event cannot be determined before it occurs, but it may be any one of several possible outcomes. That is why I mentioned that it is a measure of uncertainty, because the outcome cannot be determined before it happens. So let's talk about sample space, event, and outcome. Looking at a diagram below, you can already tell what is a sample space, what is an event, and what is an outcome. The sample space actually contains the whole rectangle. Everything inside the rectangle or the box here is part of the sample space. In set theory, it is called as the universal set. It is a set of all possible outcomes equally likely of an experiment, because we talk about random event or random phenomena. An event is any subset of a sample space. You could see here that we have three subsets of a particular sample space. So these three are our events. And each event has various possible outcomes. You could see here that each of these events has various possible outcomes with different or distinct probabilities, and all of which are contained within the sample space of the experiment. So what is an experiment? Basically, an experiment in theory or in practice is anything that we do that has possible outcomes. An outcome in probability is a result of a probability experiment. So we're going to have examples of this later. So we're going to start with discrete probability distribution. So there are, of course, many characteristics here specified on the right, and the definition of a discrete probability distribution. Actually, when we say discrete probability distribution, it is a kind of probability where we have countable or finite outcomes. An example of this is rolling a die, where we have 6 faces. So the possible outcomes are 1, 2, 3, 4, 5, and 6. So it's finite, and we can count all the possible outcomes. That is the meaning of discrete probability distribution. Another example, of course, is throwing a coin where we have two possible outcomes. Either it is a head or a tail, right? So that is basically what is discrete probability, or what a discrete probability distribution is. A basic or most common example of discrete probability is binomial probability. So what is binomial distribution? When I say binomial, actually it refers to any probability of exactly x successes on n repeated trials. We're going to discuss about what is x and what is n later, using an example in an experiment which has two possible outcomes. So we are dealing with a binomial experiment here. So the formula is P of x is equal to n choose x times P raised to the power of x times Q raised to the power of n minus x. So x here actually is the number of times for a specific outcome within n trials. In combination, it is the number of items that we choose. Okay, for example, there are 5 items and we choose 2, our x is equal to 2. So the order does not matter because it is combination. So let us have an example for you to understand what is n, what is x, what is p, and what is q. Okay, so there are many examples of binomial events in reality. An example of that is, of course, gender, where we have male or female, binary numbers, 1 or 0, responses, yes or no, color, black and white. Okay, the possible outcomes in a module, pass or fail. We have true or false for a statement. And here we have boy or girl, same with male or female. And A, not A, exists, does not exist. So there are so many events in real life where we have binomial situations. Okay, so this is a particular problem about discrete binomial probability. So it is discrete because we can count, and binomial because it has two possible outcomes. Now here, a computer check is conducted 3 times. That's the meaning of thrice, to determine whether a virus exists or not. And assuming that x is the number of observations that the computer is infected by a virus, you're going to construct a discrete probability distribution of x and find the probability that at least 2 observations shows that a virus exists. Okay, so the formula, as I mentioned, is n choose x times p to the x times q raised to the power of n minus x. So let us identify all of these variables. Now, let's first try to understand this problem. This particular problem involves binomial probability because it has 2 possible outcomes. The first outcome is a virus exists and virus does not exist. So we have 2 possible outcomes. So it is binomial probability. And of course, we have 50% for the first outcome, and the other one is 50% because it's 1 over 2. Virus exists, 1 possible outcome divided by 2 because there are 2 possible outcomes. So that's 0.5 or 50%. There is only one possibility that the virus does not exist. So 1 over 2 is also 50%. All right, so here the number of trials is equal to 3, that's our n, because we're going to conduct the check or the test 3 times, thrice. So our n is equal to 3. And the question is at least 2 observations that a virus exists. The meaning of at least 2 is greater than or equal to 2. It means that our x is equal to 2 and x is equal to 3, because we're going to conduct the check only 3 times. So greater than or equal to 2 in this scenario means 2 and 3 only. Okay, so we're going to stop during the third check. Okay, so first check, second check, and third check, and stop there. And from there, we're going to identify whether a virus exists or not. So this is our formula. Our n we know already, that is 3. And P here is basically about the question. The question is about observation that shows that a virus exists. So P virus exists is given already here on the left. That is 50% or 0.5. And Q is the opposite. Okay, please take note. P is what is asked in the problem. Okay, and we call that as the P of success. And the opposite is Q, and we call that as the P of failure. Okay, here success is virus exists, and failure is virus does not exist. All right, so success and failure here are not actually like, the success and failure in reality, where we talk about succeeding or failing. Here we talk about what is us in the problem, okay? And the opposite of that is Q. So our x is equal to 2, that is P of x equals 2 is getting 2 observations. We're going to start with 2 because at least 2, okay? So our n will become 3 here because we have 3 trials, thrice, and x is equal to 2. And our p is 0.5, 50%, raised to the power of x, so raised to the power of 2, times our q is 0.5 again, raised to the power of n minus x, so that is 3 minus 2. So in the calculator, you're going to press 3, NCR2. So please find NCR times 0.5 raised to the power of 2 and multiply 0.5 again raised to the power of 3 minus 2. The answer of that is 0.375 or 37.5%. Now, without a calculator, for 3 choose 2, we can also calculate this manually using the formula. The formula for a combination is n factorial over r factorial times the quantity of n minus r factorial. Our r here is basically our x, okay? So our n is 3. So you have 3 factorial over 2 factorial. That is our x. Okay, open and close. Our n is 3 minus 2. Then we have factorial. So 3 factorial means 3 times 2 times 1. We multiply in descending order until we get 1. And below we have 2 factorial, that is 2 times 1. And here we have 3 minus 2 factorial, that is 1 factorial or 1. So basically this is equal to 3, 6 divided by 2. So 3 times the remaining on the right is equal to 0.375. So using a calculator actually is very easy. It will just take a few seconds to get the value. All right, so now for x is equal to 3, that is 3 choose 3 because our x is 3. Then 0.5 raised to the power of x. So raised to the power of 3 times our q is 0.5 raised to the power of 3 minus 3. And that is, of course, equal to 0.125. So you have to press 3 NCR, 3 times 0.5 raised to the power of 3 times 0.5 raised to the power of 3 minus 3 is equal to 0.125. So the final answer actually is that to add the values 0.375 plus 0.125 equals 0.5, which is 50%. So that is the probability that at least 2 observations shows that a virus exists, right? So this problem actually can also be solved using another method. Okay, so here the answer is 0.5. Let me show this using another method, using propositional logic actually. So we can use a truth table to identify the value here. So we let T equals the virus exists and F is equal to virus does not exist. So again, it is binomial because there are 2 possible outcomes, T or F. So in our propositional logic, actually, we have true or false. So true could be anything. You can, actually swap the two or interchange the two. You can have F as virus exists and T as virus does not exist. It's up to you. It does not matter. Okay? So T could be anything and F could be anything in real life situation. So in this case, about virus exists and the opposite. So our table, of course, consists of 8 possible outcomes. We have the first column as T, 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 F, 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 F. Okay, please refer to this. I want you to review the propositional logic topic when we have 3 possible outcomes, 3 propositions. The second column is double T, double F, double T, double F, and the last is TF, 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 TF. So these are 8 possibilities because we have to conduct the computer check 3 times. So it could be TTT as the first possible outcome. It means that the virus exists during the first peak. During the second peak of the computer, the virus exists again. And during the third peak, again, virus exists. Or the last outcome could be FFF. It means that first computer, virus does not exist, as well as the second and the third. Okay, so 2 observations, at least 2. It means 2 or more. So 2 or 3 because we have only 3 times. So it could be TTT. That's the meaning of at least 2. First outcome or the second outcome, TTF, because you have 2 here. 2 observations showing that a virus exists. Or it could be TFT, first and the last computer show that the virus exists, or it could be this one, the 5th one, FTT. The last 2 computers show that the virus exists. And there are no other possibilities there where we have at least 2 observations showing that the virus exists. So we have 4 possibilities. And there are 8 total possibilities. 1, 2, 3, 4, 5, 6, 7, 8. 4 over 8 is equal to 0.5 or 50%. So that is equal to the first method here, 50% also. Okay, so we can actually solve the problem using propositional logic, as shown here, where the answer is 50%. But in some cases, we cannot use the table or propositional logic to solve the problem. So we have to stick to the formula only. Okay, like this second example. Here, we have 45% So 45% of customers usually buying Toshiba laptops and 55% for other laptops. Now, assuming that a group of 4 customers enters the store, find the probability that at least 2 of them ordering or buying 4 Toshiba laptops. Okay, here we cannot use actually the table because the percentages are given already. Okay, so the only way is to solve this using the formula. Again, our formula is this, where we have to find N, X, P, and Q. Okay, so the question is about, okay, buying Toshiba laptops, and it's given already. It's 45%. And again, we have at least 2. So we have here 4 customers. So it is 2, 3, until 4, greater than or equal to 2. So the probability of buying Toshiba is our P, that is the question. So that is equal to 45% or 0.45. Other laptops, that's the opposite, of course, 55%. That is our Q. Sorry. Okay. So we have here already the probabilities. Our P of X is equal to 2. That is, of course, 4 choose 2, because you have a group of 4 customers, times our P is 0.45 raised to the power of X. That is 2 times 0.55 raised to the power of 4 minus 2. Always subtract this 2. So using the calculator, that is, of course, 0.3675375. So what you're going to do is to press 4, NCR2, and then these values. For P of X is equal to 3, that becomes 4 choose 3 times 0.45 raised to the power of 3 times 0.55 raised to the power of the difference of these 2. So the answer will be 0.200475. For P of X is equal to 4, that is 4 choose 4. So multiply by 0.45 raised to the power of 4 times 0.55 raised to the power of the difference of these 2. Okay, so the answer is this. And then combine all the values. That would be 0.169185 or times 160.90% to decimal places. Okay, so this is the answer to this particular problem. All right, so this is 4 here because our N actually is equal to 4 because we talk about a group of 4 customers entering the store. All right, so let's now proceed to some of outcomes using 2 dice. Actually, when you talk about 2 dice, the total number of outcomes is 36 because the first die has 6 possible outcomes and the second die has also 6 possible outcomes. So the formula is 6 raised to the power of n, where n is the number of dice. So 6 squared is equal to 36. Now, if we're going to add the outcomes, the lowest sum is 2, that is 1 plus 1. And the highest sum is 12, that is 6 plus 6. The first set of pairs is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. And then followed by 2, 1 to 2, 6, 3, 1 to 3, 6, 4, 1 to 4, 6, 5, 1 to 5, 6, and the last set contains 61 to 66. Okay, so here, as you can see in our table, the lowest sum, as I said, is 2, and the highest sum is 12. So if you're going to look at it, the only pair that will get a sum of 2 is 1, 1. So there is only one pair. Okay, to get 3, there are 2 pairs. That's 2, 1 and 1, 2. 4, we have 3. That's 2 plus 2, 3 plus 1, 1 plus 3. So in your exam, this is in any order. So you can have 1, 3, 3, 1, 2, 2. And 5, there are 4 possibilities, 2, 3 until 1, 4. 6, we have 5, 2, 4 until 1, 5. And 7, we have 6, 2, 5 until 3, 4. Okay, so the formula actually is -1 to get the number. 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1, 5 minus 1, 6 minus 1, 7 minus 1. Now, as soon as you get 6, you have to go back to 5 until 1. So 1, 2, 3, 4, 5, 6. Then 8, there are 5 pairs. 2, 6, 6, 2 until 4, 4. And then 9, 4 possibilities. And then 10, there are 3. 11, 2, 12, only 1. That is 6 plus 6. So on your test, you don't need to create this whole table. You have to create a table based on the question. Now, the question here is find the probability that the sum of the outcomes is greater than 7 using a table of sample space. So basically, what we're going to do is just to show the sum of 8 until 12 because greater than 7. So we don't need to specify the whole table. So in this case, we have to show only from 8, 9, 10, 11, 12. So our numbers are 5, 4, 3, 2, 1. Basically, if you have after 7, you start from down, bottom up. Okay, 12 is 1, and then it goes to 2, and so on. Okay, so it's easier to use a bottom-up approach. And here again, as I mentioned, this is in any order. You can start from 3, 5, or 5, 3, 4, 4, and so on, as long as the sum is 8. And here as well, you can start from 4, 5, and 3, 6, 6, 3, 5, 4. Okay, so these are the sample points. Then add all the sums, or you can add the numbers here. 5 plus 4 plus 3 plus 2 plus 1 over 36, because here we have 36 all in all. So 15 over 36, that is 41.66%. Okay, so that's all for now. I'm going to continue with the rest of the problems in the next video. Thank you so much for watching. Until the next time, bye-bye.